Hello and welcome back to the Botronix Lab's Robotics programming course. In this video, we're continuing our journey into Python GUI programming with Tkinter, and today's focus is all about making our GUI more organized and interactive. Last time, we created a basic window using Tkinter. Now, we're going to learn how to group buttons using frames, lay them out neatly using grid, and even make them respond to clicks, all important steps toward building a fully functional control panel for our Pico Otto robot car. Let's get started. Alright, let's kick off step 1 of module 2 where we start organizing our robot GUI using something called a LabelFrame. In the last module, we learned how to create a basic window and set its size. Today, we'll take a big step forward by creating a grouped section in our interface, perfect for organizing related controls, like movement buttons for your Pico Otto robot. In GUI design, keeping things organized is critical. That's where LabelFrame comes in. It's like a regular frame, but with a built-in title. It helps you visually separate one group of widgets from another, making your GUI cleaner and easier to understand. Let's look at the code and break it down. Here, we set up the main window, give it a title, and fix its size to 300 by 300 pixels. This makes sure our layout stays consistent across all platforms. Now we create the labeled frame. This line creates a titled box called Movement Controls. The padding ensures that whatever we put inside the frame won't be squished against the border. The groove effect gives it a 3D border that's great for grouping. To make sure the frame shows up even when it's empty, we give it a default size using .config. That makes the frame visible right away, even before we add any buttons. And just to make things clearer, we add a temporary label inside the frame. This acts as a visual cue for what's coming next. Finally, we start the GUI event loop with root.mainLoop. That's what keeps your window running and responding to user input. So, that's it for step 1. A titled, padded frame that's clearly visible and ready for action. In the next step, we'll use a layout manager to position our control buttons just like a D-pad. Let's move on. In this step, we're going to start populating our movement controls frame with real buttons, and we'll arrange them like a D-pad using Tkinter's powerful .grid layout manager. Why .grid instead of .pack? Well, .pack is great for stacking widgets vertically or horizontally, but .grid gives you precise control by placing widgets into rows and columns. Think of it like a spreadsheet. You can tell each widget exactly where to go. Let's first add our 4 direction buttons: forward, backward, left, and right. Now here's the magic of .grid. We're going to position the buttons like this. Forward goes on top in the center. Left and right go in the middle row, on the left and right sides. Back goes at the bottom center. The pads and payD values create some space around the buttons to prevent them from getting cramped. Now when you run your app, you'll see a neat control layout, the kind you might use to drive your robot with arrow buttons. And remember, .grid only works well when you're laying out multiple widgets in rows and columns, especially great for control panels like this. Now it's time to make those buttons actually do something when we click them. We'll connect each button to a specific function, like move_forward, that will trigger an action when clicked. For now, we'll just print a message to the terminal, but later on, these functions could send commands to your robot. Let's create a simple Python function for each direction. Each of these functions just prints a message, a great way to test that your buttons are wired up correctly. Assign the functions to the buttons using the command parameter. This is where we tell each button what to do when clicked. With this setup, clicking any of the buttons will trigger its corresponding function and print a message in the terminal. What's really happening here? Each button in Tkinter has a command property that runs a function when the button is pressed. This is one of the most important interactions in GUI programming, connecting what the user does to what your app does in response. So give it a try, run your program and click the buttons. This is a super useful way to test your app logic without needing any robot hardware just yet. Later, we'll replace the print calls with real robot control code. Your GUI is functional and interactive. Now let's make it look more polished and user-friendly. We'll add a section title to clearly label our control area. This improves readability and gives our app a clean, professional structure. Users need to quickly understand what each part of your app does. A label acts as a heading, just like titles on websites or forms. It improves the user experience and adds a visual hierarchy to your layout. Let's use the label widget and place it at the top of our window. This creates a bold title using a larger font size, with some vertical padding, pd equals 5, to separate it from the top of the window. And that wraps up Module 2 of the Botronix Labs Robotics programming course. You've now learned how to structure a GUI using frames, position widgets with .grid, link buttons to actions, and improve your interface using section titles and styling. What we built today forms the foundation of a real robot control panel, complete with directional commands and a clear, organized layout. This is a huge step toward building a fully functional robot interface for your Raspberry Pi Pico Otto project. In the next module, we'll continue by adding sliders, input fields, and dynamic widgets that will make your GUI even more interactive and responsive. Download the full example code from the comment section below. It's ready for you to copy, modify, and experiment with. If you're enjoying this journey, don't forget to hit that like button, subscribe to the channel, Botronix Labs, and turn on notifications, so you won't miss the next module. Your support helps us keep making awesome tech content for builders, makers, and future robotics engineers like you. Until next time, keep building, stay curious, and code with purpose. See you in Module 3.